Assalamualaikum and good morning. We are from G01 group SH1. Our members are ATHIRAH, FARIQ and me AININ. Today, we will delve into the false position method, a numerical technique used for finding roots of equations, also known as the regular falsy method. It's an iterative approach that refines the root by narrowing down the interval where it lies. In essence, the method combines aspects of the bisection methods with linear interpolations. The false position method is particularly useful when dealing with nonlinear functions and provides a balance between simplicity and convergence speed. Now let's explore the steps and dynamics of this method in more detail.
Hi, I'm ATHIRAH and I'll be explaining false position in Excel. First, this is how our Excel would look like, and below is our equation. Now I'll explain the first half part. We have to know that A and B is a value that we choose, but we cannot just choose randomly. There is a condition to be met. The condition is either FA or FB must be negative. In this case, we must do try and error until we get either FA or FB is negative. Next is our C value. C is obtained through a formula, so we just type in our formula and substitute the value that we have set. Next step is to search for FC. FC is just a value that obtained by substituting C into the equation. And then we'll move on to the next part, which is FA times FC and FB times FC. These two are used to determine whether C will be replaced by A or C will be replaced by B. It will determine whether the root is located at the left side or the right side of the graph. Last but not least, root present between A and B is just for a confirmation whether the root is present or not for the whole graph.
Now, for the first iteration, we are going to assign the values of A and B using the product test that we have done previously. Now, for the values of A, if f of A times f of C is less than 0, the root is between A and C. If f of B times f of C is less than 0, then the root is between B and C. Then, for the values of error, we take the C value of this iteration minus the value of C from the previous iteration. Now, we repeat all the steps for our next iterations until we get the value of our root with an acceptable error. Now, as you can see, the value of our root is approximately 0.5687293. We can also visualize the false position method by plotting a graph, and this can be done by creating a table with our x and fs values and the values of our iterations. Now that is all from us. Thank you.